All right, so this is modeling how to complete the square. Again, once you see a quadratic equation where it's already set equal to 0, and the a term and the b term and the c term are all present, none of them is missing, I know that I should try to do the diamond. But 4 times 25 is 100, 16 on the bottom. If I'm looking for two numbers that multiply to make 100, yet add to 16, since they're both positive, there is no solution here, right? The square root of this would be 10 times 10. That's as small as it's going to get. As I split it up the other way, I would get like 20 times 5, 25 times 4. They're just adding up to bigger and bigger numbers. So I can't do that. So this is a candidate for completing the square. Step one is I'm going to take the 4x squared plus the 16x. I'm just going to move the 25 out of the way. I like to move it to the other side. And now I need to get this to be a just x squared. So I recognize that both of these have a common factor of 4. So I'm going to pull that 4 out, leave me with x squared plus 4x plus a blank equals negative 25. Now we have to turn this into a perfect square. In other words, this whole expression is going to end up being 4 on the outside, something squared equaling some constant over here. And I know that when this thing does a perfect square, whatever this first term is going to multiply together to make x squared. So this is definitely x. And whatever this second term is, it's going to square to make this one. So I like to find this term next. And it's easy because as a perfect square, it's just going to be half of 4, half of whatever the b is. So in this case, that would be a positive 2. But now I have to finish it and figure out what goes inside here. When I square this, I'm going to get x squared plus 2x plus another 2x makes 4x. And then here is going to be plus 4. I've necessarily filled this in to make a completed square, which is what I wanted to do. But I've now tilted the equation. I've added something into the equation that's going to make it left heavy. So I have to balance it. And because this was inside parentheses, where 4 was being multiplied, even though I've added 4 to this side, it's really bigger than that. It's 4 times as big. 4 times 4 is 16. So I've really added 16 to this side already. So to keep it balanced, I have to add 16 to this side. Negative 25 plus 16 is going to give me negative 9. And now to solve this, I'm going to use the square root idea. I'm going to get rid of the 4 by dividing both sides by 4. Get x plus 2 squared equals negative 9 over 4. Now I'm going to get rid of the square root. X plus 2 is equal to the square root of negative 9 over 4. When I introduce the square root like this, it becomes plus or minus. And now I'm going to simplify this as best I can. Let's see, plus or minus, that's the same as square root of negative 9 over square root of 4. Well, this is going to have 3 times 3 times negative 1. So I can treat this as I times 3. And this is going to be square root of 2 times 2, which is 2. So now I've got x plus 2 equals plus or minus 3 halves I, and I need to isolate x. So I'm going to subtract 2 from both sides. X equals negative 2 plus or minus 3 halves I. This looks like I made that a square there.